Hi, everybody. Welcome back to the Best Year of Your Life Summit. I'm your co-host, Lori Gambacorta, and I'm absolutely thrilled to be here today with Ari Whitten. Ari is the founder of the Energy Blueprint. He's a natural health expert who takes an evidence-based approach to human energy optimization. He has deep expertise in mitochondrial health, circadian rhythm and sleep, nutrition, gut health, light therapies, fitness, and hormetic stress. Ari has extensive experience in clinical psychology, an MS in human nutrition and functional medicine, a BS in kinesiology, and 2 advanced certifications from the National Academy of Sports Medicine. Ari is the author of The Ultimate Guide to Red Light Therapy and Eat for Energy, How to Beat Fatigue and Supercharge Your Mitochondria for All-Day Energy. Thank you so much for being with us here today, Ari. I'm just so thrilled that you're going to be able to talk to people today about how they can live the best year of their life.
Lori, it's an absolute pleasure to be here. Thank you so much for having me.
Great. Today, we're talking about physical health and specifically creating daily energy and lifelong wellness. So, as the founder of the Energy Blueprint, you're known for your evidence-based approach for helping people boost their energy. So let's start by talking about what are some of the common reasons for fatigue and low energy, even some of the ones that people might not be aware of.
So it's a big, very long answer with a lot of different aspects to it. Let me see if I can provide sort of an overarching framework to simplify it, and then we can dig in from there into specific topics. So the main problem that leads to chronic low energy levels is lack of energy production at the cellular level. So it's important to understand that is the fundamental physiological mechanism that is mediating this problem. There's lots of competing theories and hypotheses as to what's going on. So for a long time, for example, adrenal fatigue is the dominant school of thought in the natural health community around what's causing fatigue. And the idea is that chronic stress is essentially wearing out our adrenal glands, burning them out or exhausting them to the point where they can't produce enough cortisol. And cortisol is this hormone that is involved in sort of releasing blood sugar and keeping blood sugar levels stable and a few other things, combating inflammation and things like that. It's an important hormone that's involved in the stress response. And as a result of chronic stress sort of wearing out the adrenal glands, then you get chronic fatigue as a result of too low of cortisol, for example. In the conventional medical community, there really is no model to explain chronic fatigue. They don't have any particular conceptual framework or paradigm to explain, what regulates human energy levels, what lowers energy levels in various people. What they would do is essentially test you, run standard lab testing to determine if you have some other diagnosable dysfunction or disease state. And to the extent that something shows up there, they would treat whatever shows up there. It's important to note, and there's a paper, we could talk in depth about the conventional medical approach to this, but there's a paper basically where they've shown that in 95% of cases, people with chronic fatigue who go to their doctor, who get these standard lab testing, blood testing done, in 95% of cases, there are no particular abnormalities that show up that indicate any particular disease or abnormality that could be treated. In 5% of cases, people might have anemia or they might have hypothyroidism or something like that. And then they say, okay, well, here your fatigue might be caused or is probably caused by this particular disease or dysfunction. Let's fix it. Here's some thyroid hormones. Here's some iron or B vitamins to treat your anemia. But again, let me repeat, 95 out of 100 people with chronic fatigue don't have anything that shows up on their blood test results that explains their fatigue. Now let's go back to the adrenal fatigue thing for a second. This was something that many years ago I spent really a full year of my life reviewing the scientific literature on. And there's a whole big backstory I could tell you about why I did that. Actually, I originally went into it with the intention to prove the existence of adrenal fatigue, because I discovered that within conventional medical circles, the whole concept of adrenal fatigue was really brushed off as pseudoscience and nonsense. And at that time, I was a big believer in adrenal fatigue and advocate for it. A lot of mentors and people that I respected, that I had learned from for many years and studying natural health, spoke about adrenal fatigue. So I assumed it was very real. And when I discovered in conventional medical circles they think it's nonsense, that really sort of irked me and led me to do a deep dive in the scientific literature, essentially with the intention to prove that, here's the science that shows adrenal fatigue really does exist. And when I did that, I basically, after many months of digging into that literature, I essentially disproved my own hypothesis. I debunked my own beliefs, essentially, and discovered that the evidence really does not support the existence of adrenal fatigue. And it certainly does not support the idea. Two aspects to it. One, it doesn't support the idea that chronic stress actually wears out our adrenal glands and results in low cortisol. So that whole premise is wrong. And number two, more importantly, the idea that people with chronic fatigue and these sets of symptoms, burnout, chronic fatigue type of symptoms, have low cortisol levels is wrong also. The vast majority of science, and there's several dozen studies that have tested this, show no particular difference in HPA axis function or that's hypothalamic pituitary adrenal axis function or cortisol levels in normal healthy people versus people with various chronic fatigue type syndromes, stress-related burnout, burnout syndrome, clinical burnout, chronic fatigue syndrome, et cetera, et cetera. You can find some studies going either way. The vast majority of studies show no difference. So the idea that the adrenals and cortisol explain this is also not accurate. So what is accurate is that cellular energy production is low. Now, why is it low? What's this is another aspect of things that we modern humans in this particular day and age, both within conventional medical and I would argue largely in a lot of alternative health and natural health and functional medicine circles, have mastered the art of conflating micro level mechanisms, cellular biochemical mechanisms of particular phenomena with causes of them. Okay. And we think that the more we zoom in with a microscope to peer into the micro level mechanisms of what's happening inside of cells and what's happening inside of our blood, the closer we are arriving to the true level of causation of these problems. And it's simply not accurate. To give an analogy, it's like if you had a house plant in your house and you started to notice that the leaves were browning and the plant was wilting. And you said, well, let's go in and, let's take some samples of these leaves and, put them under a microscope and do various testing in a lab to see what kind of biochemicals are involved in this process of the leaves turning brown or the plant starting to wilt. And then we found biochemical phenomenon that could explain that. And then we said, oh, we've discovered the cause of this browning, right? It's the P450 chlorophyllase enzyme that is causing the leaves to turn brown.
Right.
Okay? And of course,
it's really the result.
Yes, of course, that is not accurate. And we all understand this very well with a houseplant, where we would instantly recognize that it's not some internal biochemical phenomenon that's the problem. It's if the plant is dying and struggling, it's because the conditions, the environmental conditions of that plant involving sunlight, air, soil, and water, something is off there. Something is not right. Could be too much water, could be too little water, right? Could be too little sun, too much sun. But something is the actual cause of those leaves turning brown and the plant wilting. And this is the big thing that most modern humans are very, very bad at. We tend to confuse the micro level mechanisms with causation, and we have a very difficult time tracking whatever's happening at that level back to the macro level. So let me ground it in a bigger picture context very briefly. There is a term called mismatch diseases. Okay, and this is also called evolutionary mismatch. And these diseases are also called diseases of civilization. And the reason that these diseases are called diseases of civilization or mismatch diseases is because they are fundamentally caused by a mismatch between our biological design from evolution and the modern environment and way of life. Now, what's important to understand is that this is not a trivial concept. This is not a concept that just explains this disease or that disease. This explains almost the entirety of the modern chronic disease burden that afflicts modern humans. Everything from heart disease to cancer to obesity to diabetes to metabolic syndrome to hypertension to almost all of the major killers. And it explains the vast majority of the burden of chronic fatigue as well. Okay, so this is a condition or a physiological dysfunction that is fundamentally caused, this low cellular energy production is being caused by the modern environment and way of life. So I'll leave it there for now. There's lots of details to explore.
Yeah, there are details to explore. So before we move on to talk about mitochondria and mitochondrial health, what are some of the mismatches? Yeah, what are the mismatches? I mean, I think that I know what some of them must be, like environmental toxins, and we're not spending enough time in the right kind of sunlight, and that's affecting our circadian rhythms. Like, what else?
Yeah. So Daniel Lieberman, who is a Harvard evolutionary biology professor, he's the head of the department at Harvard evolutionary biology, and he's the author of the wonderful book called The Story of the Human Body. And the way he breaks it down is that there are three fundamental types of mismatches, categories of mismatches. And they are things that we're getting too much of, things we're getting too little of, and things that are too new. Okay? And too new such that our bodies are not well adapted to handle them. Okay? So,
such as like genetically modified food or artificial colors, would those be?
Yes, GMO food is a sort of contentious one. So, I would say that it would be better to stick to sort of examples that are less controversial, but potentially yes. So, too much. What are we getting too much of? All right, we have a diet that is an extremely calorie-rich, processed food-rich diet. That's rich in what's called hyperpalatable food, which tends to be a mixture of sugar and fat and starch, sometimes salt, sometimes the texture of crunchiness. And this hyperpalatable, calorie-rich diet and calorie-abundant environment with enormous ease of access to these foods. So in the ancestral environment, not only were these types of foods harder to come by, most of these foods didn't even exist. If you did get something that was calorie rich, you had to work for it. It wasn't just you didn't walk 5 steps over to your refrigerator or drive over to a fast food restaurant or a grocery store. You had to work for the food you get. So energy expenditure was involved in energy acquisition. And whatever energy you required was not anything like the modern food environment. Okay, so we have way too much of that hyper palatable, calorie rich diet drives an enormous burden of obesity, diabetes, metabolic syndrome, and widespread metabolic dysfunction that is a fundamental driver of many, many other diseases, including heart disease and cancer and dementia and Alzheimer's, many, many other conditions as well, and chronic fatigue. Okay, so that's just one layer of the story of what we're getting too much of. We're getting too much of environmental. Well, I'll leave that one. Let's go to too little, just for the ease of brevity, because I'm talking a lot here in my answers. So too little, what are we getting too little of? Number one, physical movement. Okay. Physical movement is not a trivial thing in human life. It is an absolute essential thing for normal function of the cells and tissues and organ systems of our body. You cannot be healthy when you have too little physical movement in your life. And it's also the case that just going to the gym a few times a week for half an hour or an hour, and then being mostly sedentary the rest of the time is also inadequate. Humans are meant to move. We are designed to move. Our physiology evolved to expect us to move frequently throughout the day. And when we don't have it, it is absolutely a major driver of physiological dysfunction and disease and accelerated biological aging. Things that are too new, environmental toxicants, right? We have many synthetic compounds, man-made compounds. Microplastics are ubiquitous in our environment. We have phthalates, we have endocrine disrupting compounds, we have pesticide and herbicide residues in our food, in our water. We have pharmaceutical drug residues in our drinking water. We breathe toxins in our air, we get it in our water, we get it in our food. And our physiology is not well adapted to process these compounds in a way where it's able to completely neutralize them. So in other words, these things cause harm. So that gives you a few bits and pieces of each category.
Right. So these three examples of the mismatch, too much, too little, and too new, how do they affect mitochondrial health? And then what are some of the strategies that you can share with people for reversing that and optimizing their mitochondrial health in the face of all of these challenges?
Yeah. So there's a researcher named Dr. Robert Naviaux, and about 10 years ago, he published an amazing paper called The Cell Danger Response. And this really changed our understanding of mitochondria in a profound way. So first of all, let me say, I mentioned earlier, fatigue can essentially be thought of as a deficiency in cellular energy production. The main thing, I'm just stating this directly to make sure people understand, the main thing that is responsible for cellular energy production is our mitochondria. Okay, so Robert Naviaux published this paper called The Cell Danger Response that really sort of massively expanded our understanding of what mitochondria actually do and their importance in human physiology and human health. So we all learned about mitochondria, in grade school and in high school biology and in college physiology courses and biochemistry courses. And for the most part, mitochondria are really framed as these sort of mindless energy generators. They take in carbs and fats, and then they pump out ATP, adenosine triphosphate, which is cellular energy. And that's really how we learn about them at more sophisticated levels in physiology and biochemistry courses. You start to learn about the electron transport chain, and you memorize the steps in the process of, NADH and so on, and complex 1, 2, 3, 4. And but for the most part, fundamentally, the whole meta level understanding of what mitochondria are doing is just transforming food stuff into cellular energy. But it turns out that mitochondria really play a much bigger role in human health than most of us realized up until Naviaux's work. And what he did was essentially in his words, I'll put it this way as a framework. He described mitochondria as the central hub of the wheel of metabolism. Metabolism is a word we often associate with weight loss and how many calories our body's burning, but the actual meaning of metabolism is the totality of all biochemical reactions that are occurring everywhere in our body. Okay, so it's everything that's happening in our body. Mm-hmm. Mitochondria are at the center of that. Okay, now in his work, he essentially describes not just one role of mitochondria as energy generators, but two key roles of mitochondria. In addition to their role as energy generators, they are also serving as environmental sensors. Okay, so they are not just producing energy, they are also asking the question, is it safe for us to produce energy? And they're constantly taking samples, essentially, of what's going on inside the cell, what's going on inside the body, to assess whether it is safe to produce energy. So there's something that's important there. The body produces abundant energy when it perceives itself to be in a safe environment. When it doesn't, when it detects that danger is present, when those mitochondria, they're like, you can think of them as like canaries in the coal mine. They're sensing danger is present, something is wrong. When they start to pick up signals that something is wrong, they turn down the dial on energy production and shift the cellular resources towards cellular defense. Okay, so think of it like you're in your kitchen preparing dinner, and all of a sudden a criminal breaks in and holds a knife up to you and said, give me all your jewels, give me all your money, right? You're not going to just carry on preparing dinner and for your family. You have to deal with that threat.
Yes.
And that is what mitochondria do. So they are the core mechanism that is, let me put it this way. There are many steps in the body, many aspects of our physiology, many mechanisms, many different hormones, neurotransmitters, all kinds of different molecular and biochemical switches that are in one way or another involved in energy production. Okay, just like if you think of a car, there's like if you take away the engine block, the car's not going to function. If you take away the spark plugs, the car's not going to function. If you take away the wheels and tires, it's not going to function. There's lots of pieces that are necessary for the car to function. But what's important is to distinguish a part that is required for normal function from the thing that is the most upstream, that is actually regulating and making decisions about all of the steps of the process. So the human sitting in the car, turning the engine on and deciding whether to press the accelerator or the brake and how hard to do so. And this is essentially what the mitochondria are doing. They're in the position of deciding whether we should press the accelerator or the brake and how hard we're going to press the accelerator or the brake. And they do that accordingly to signals they are picking up on in the environment about whether it is a safe environment or whether the body is under threat or under attack.
And so these three levels or categories of mismatches that you're talking about, I'm assuming then are pushing us into that sort of cell danger area.
That's right. So, and there's various ways that this is triggered. The mitochondria don't have a receptor for this toxin and that toxin, and they don't have a receptor for alcohol and a receptor for pesticide residues and a receptor for psychological stress and a receptor for sleep deprivation or something like that, or a receptor for a poor diet. Almost everything that is harmful to human health ultimately gets translated into a few different things. Reactive oxygen species or free radicals, reactive nitrogen species sometimes, or inflammatory cytokines. And there's one other key mechanism that's involved here, which is what's called purinergic signaling. And this has to do with contents like ATP and ADP, energy molecules, that should be inside of the cell. But when they are detected outside of the cell in the extracellular environment or in the blood, or even things like mitochondrial DNA, which should be inside of cells, when they start floating around in the extracellular environment, or in the bloodstream, those actually get picked up on as signals that the body is under attack, because it's a sign that cellular damage is occurring. So if cellular damage is occurring, then you have leakage of what should be internal cellular contents into the extracellular environment. And through those mechanisms, whether it's picking up on inflammatory cytokines, picking up on reactive oxygen species, or picking up on signals that indicate cellular damage, basically the mitochondria can detect almost every kind of stressor imaginable. Everything from pathogens to injuries to psychological stress to a poor diet to poor sleep to environmental toxicants and anything else you can imagine. Almost everything gets ultimately translated into one of those signals, and the mitochondria say, oh, okay, something's wrong, we're under attack in some way, and let's turn down the dial on energy production and deal with this threat.
That model makes a lot more sense to me than just a model of, the mitochondria are just producing energy all the time, regardless of what's happening around it.
Well, think of it this way. If the mitochondria are just sort of mindless energy generators, why wouldn't just simply sitting around and eating more food, providing more fuel to them, give you more energy?
Right.
In fact, it does.
Clearly, it does not. It does the opposite. Right.
Exactly. Yeah. Right. Yeah. So, like, just let's look at what that one layer of the story. Why does it do the opposite? Well, excess consumption of fuel is actually metabolically toxic. It causes damage. To have excessively high blood sugar or excessively high blood fats actually is harmful to the cellular environment and causes damage to cells. And so insulin resistance, believe it or not, it's often pathologized, but it's actually part of our body's protective mechanism to not allow too much sugar and too much fat into the cell where it creates damage. Insulin resistance is part of the body's mechanism of protecting the cells from damage, keeping that stuff in the bloodstream instead of allowing it into the cells. And when we have that sort of environment from chronic overconsumption of fuel, it is cytotoxic and mitotoxic. It is directly toxic to mitochondria and results in metabolic dysfunction and chronic inflammation and oxidative stress. And the mitochondria start to pick up on it. So the story of energy is definitely not as simple as, hey, just provide more fuel to your mitochondria. In fact, for the vast majority of people, it is the exact opposite.
So what are some of the other things? So now that you've explained the role that mitochondria play on an in-depth level, what are some of the strategies for optimizing mitochondrial function? So clearly one is, as you said, don't overeat, choose not to eat processed food.
Yes.
What are some other ways to optimize?
Typical advice that we're going to encounter. Well, look, switching to whole foods and getting rid of processed foods, having some base level of physical activity, standard recommendations, 30 minutes a day, not smoking and drinking alcohol, and maintaining a body fat, a BMI or a body fat percentage under, I think it's 25. Those 4 things alone have been shown in numerous studies to eliminate about 80% of the chronic disease burden that we now have. Okay, and these are 4 very basic, very rudimentary steps. And this is and we're going to go considerably beyond this, but I just want people to understand that literally 80% of our chronic disease burden can be eliminated with 4 very, very basic steps. And this is not adhering to some extreme diet. 2 of the steps are just not being really overweight and moving your body a little bit each day and not smoking cigarettes, right? Like this is not a lot to ask. But just these basic steps can eliminate 80% of the chronic disease burden. But what a lot of us do is we get endlessly fixated on the next, extreme diet fad, and it just gets progressively more extreme every few years till to the point where we've essentially demonized pretty much every food imaginable that can be demonized. I think we've demonized everything except water at this point. I never imagined that I would see a day that we're demonizing even vegetables. But now we've seen even people put that forth in recent years. Just to be clear, we are not suffering, us modern humans in the last several generations are not suffering from a chronic disease epidemic from consuming too many lentils or beans or broccoli or blueberries or carrots. Okay, this is not the cause. We know very well what's causing our health problems, and it's not those things. But there's a financial incentive for diet
That
gurus.
was I was going to add. That was going to be my next question. I was like, well, if this information is evidence based, because a lot of times I'll get, as a holistic practitioner, I'll get somebody saying, well, what you're doing isn't evidence based, and it's like, well, that's not true. So yes, there is a financial incentive.
For which
Would
part? Which part are you
well, would
referring
you?
to?
Well, if we could get rid of 80% of the chronic disease epidemic by those four things that you spoke about,
Very basic things.
do
Yeah.
you think that the information about that is somehow being actively suppressed? Are we being misled? Is it individual character flaw that keeps us from following it? What's your view on that? And
You're asking big questions, and those are things. I mean, the whole hour discussion could be on those big questions. They're good questions to ask, but I'm afraid the answers are more complex. So, I mean, look, if we're talking about financial incentives, what I was just alluding to was the financial incentives among like natural health gurus trying to sell some wacky diet. But the financial incentives that really are dictating most of what you just described are big industries, pharmaceutical industry influence over the entire practice and paradigm of medicine. And they have, over the last roughly 70 years, essentially stripped our collective understanding of health from any kind of semblance of an evolutionary context, so that most modern humans don't even understand that most of our modern health problems are actually driven by evolutionary mismatch. If we do understand it, we think, oh, well, that we're so much better off than those hunter-gatherers who lived a long time ago, because they only live to age 40 or 50, which is a major myth that we could talk about if you wanted to. There's a lot of mythology that's been created around the so-called lifespan extension of the 20th century, but it is absolutely a myth. It is not what most people have been led to believe. And we have created a mythology that says that number one, most of our health problems are caused by these specific micro level biochemical cellular mechanisms. So heart disease is the result of atherosclerosis, which is caused by LDL and inflammatory molecules, leading to this change and that change and that change, which creates, macrophages and foam cells and damaging the endothelial lining. And then we get, the plaque accumulating in the walls. And therefore, what we're going to do about it is take drugs that lower cholesterol. Okay. And depression is the result of a neurochemical imbalance in your brain involving serotonin. And what we're going to do about it is take a drug that alters levels of serotonin in your brain. So again, what I was saying earlier is we've become fundamentally confused about the nature of causation. And this isn't an accident that most humans, including a lot of people in natural health circles, think this way. And it's because we have been, since we've been children, systematically indoctrinated to think this way, largely as a result of pharmaceutical industry influence over our entire paradigm of health.
I agree with you 100%. And I often tell my clients, you don't have high cholesterol because of a lack of Lipitor.
Yeah. Well, to go even one step further, let me just make the point more emphatically by saying um, the here's a different way to think about health. Okay, instead of thinking we have this disease, let's go study this disease. Let's uncover the mechanisms of this disease, so that once we understand the specific mechanisms of the cell, is this mechanism in the cell is doing this, and this molecule is doing that, which triggering this switch, and this biochemical is contributing to this, and what's LDL doing, and what's this neurotransmitter doing, and what's this hormone doing, and what's this receptor doing. And once we uncover all of those steps of that process, then we'll be able to reverse engineer our way to health by going into a chemistry laboratory and synthesizing a man-made drug, which will go into our body and block that dysfunctional mechanism or suppress it or modulate it in a way where we combat this disease process, and then we'll cure the disease so that we can be healthy. Okay? Instead of thinking like that, here's another way of thinking about health. Instead of studying disease, why don't we go study the healthiest people on earth and see what they do differently? So in the realm of heart disease, do you know who the group of humans with the healthiest hearts on the planet are? The people who have almost zero incidence of heart disease. Almost nobody dies of heart disease in this population, which is, by the way, heart disease is the number one killer in among modernized.
I should know this from, blue zones, but
It's
I
not a
don't
blue
actually.
zone.
No, it's not.
No, but it's not a bad way of thinking. But
Yeah.
it's a tribe in the Amazon in Bolivia called the Tsimane tribe, and they have the healthiest hearts and the lowest incidence of cardiovascular disease of any known humans. And it's not because they don't live a long time. I know some people listening to that are thinking this. You can do these studies, and of course, this is Science 101. The researchers do these studies in a way where they look at a specific demographic, an age group. Americans age 65 to 85, hunter-gatherers age 65 to 85. And by the way, they do live that long. In fact, one of the oldest study participant in one of the recent studies done on them was 94 years old. They live just as long as us, and they have no access to modern medicine or drugs. And they have vastly lower rates of chronic disease. They have almost no incidence of the same chronic diseases that afflict 6 out of 10 of adults in the United States.
And so they're also not exposed to these evolutionary mismatches.
Right.
Correct?
So
yeah.
This is one of the key lines of evidence that shows us that these modern diseases that afflict us are clearly mismatched diseases. Because if you go find the humans who represent the control group, who still live in the ancestral human lifestyle and therefore don't have mismatches at the level of environment and way of life, what you would predict based on what I just explained earlier is that those people who don't have those mismatches don't have the mismatch diseases. And that's in fact exactly what we find. This simple fact that I just explained to you should be regarded as the single greatest discovery in modern medicine. The fact that humans exist free of all of the diseases that we are afflicted by, that kill more than 8 out of 10 of us, and that we are desperately searching for answers for. And instead of saying, wow, this is an amazing discovery, we've learned that there are humans who don't have these diseases, let's try to move in that direction and do what they do. Obviously, we can't be hunter-gatherers living in the jungle, but let's replicate that as best as we can, because obviously it's the most effective thing available to us. And instead, what we do is we study the people with the diseases, and then we go to a chemistry laboratory and synthesize man-made chemicals to try to attack the diseases.
So let's kind of help people understand. That to me, that is important. That is the larger context, like you said. That should be like considered the greatest discovery. But
I know, and I bet you nobody else has talked about it on your entire summit, right?
Not that I've interviewed, no. Mm-mm.
Yeah. So that,
but
sorry,
so short of that, we understand the implication of that, and no, we're not going to move to the Amazon. And so short of that, let's kind of, can we break it down into, like, let's look at some of the specific things, and then ways that people can improve their circumstances, like around gut health, or sleep and circadian rhythm, for example.
Mm-hmm. Yeah. So listen, I think the main things that you'll hear people talk about within natural health and functional medicine circles, almost all of the healing that is actually being done when people actually get results. And you can cure and reverse many diseases. You can cure full-blown diabetes in a matter of weeks or months by addressing the fundamental mismatches that I just described. And there's been numerous studies that have shown this. Roy Taylor's work in particular, he's done a number of studies showing you can absolutely reverse, you can completely cure full-blown diabetes in people who have had it for many years simply through changing their diet. And the resulting weight loss that ensues, because diabetes is heavily driven by excess body fat itself. So, and there are a number of other studies that have shown profound disease reversal. Terry Walls has shown this in her work on autoimmune disease, and there's a long list of other trials. Dale Bredesen in dementia and Alzheimer's. What's his name? I'm trying to think of. Dean Ornish has shown it with regards to heart disease. What people don't really understand, because we're so locked in this model of thinking that it's all about either a drug or a supplement to fix this or that specific mechanism. The vast majority of healing that people actually get will come down to, as far as what's going on right now, mainly addressing diet, addressing physical movement, addressing sleep and circadian rhythm, addressing managing chronic psychological stress, reducing level of exposure of environmental toxicants, cleaning up your food, your air, your home environment, your personal care products, your water, and so on. And the other key pillar that is often talked about and addressed is community and social connection. And if you address those 6 pillars, and you of course do other basics like not smoking cigarettes and consuming a lot of alcohol, as far as the results people are getting right now, almost everything comes back to those things. And so there is an enormous amount of discussion already on those things. So I want to add one key pillar to this understanding. And this goes back to, part of this framework of mismatches that I was explaining earlier. Too much of certain things, too little, too novel. The too little column is really important and not very well understood by a lot of people. So one of the things that happens in our body, I'll explain this with a physical analogy first. Because we all understand this very well, this principle. If we go to a gym and we lift heavy objects, we move some weights around, and we do that frequently, we create a stress that stimulates an adaptation in our body that makes our body essentially grow bigger, stronger muscles in response to that stressful stimuli. Okay? So our physiological system is malleable. It's plastic in the sense that people have heard the term neuroplastic. Well, we have broader plasticity in our physiological systems, and they shape themselves and tune themselves in accordance with the demands of the environment. Okay. So the downside of this amazing ability to adapt to stressors in this way, to increase the capacity of our physiological systems to better handle demands like this. The downside is, unfortunately, that we are also plastic in the other direction as well, which means that to extend this muscle analogy further or example, If you break a bone and you put a cast over your arm or leg, and then 8 weeks later you go to the doctor, they saw off the cast, you will look down at your arm or leg and discover that it has shrunk to half the size. And that is muscle
Yeah.
atrophy.
Yep. Yeah, I was going to say it atrophies because the body's like, well, we don't need to put any energy there, right? Because it's
That's
not doing anything.
that's exactly right. And what most people are unaware of, and this is a really important thing, because right now so much of our health narrative is about these forces of damaging forces. Okay, so how can we, what are the damaging forces in our diet? What are the toxins that are damaging us? The sleep deprivation and psychological stress and loneliness and social isolation. And right, we have lots of talk about all of the too much category or too new category things that are
Mm-hmm.
harmful to
Mm-hmm.
us that we're getting too much of, or things that we're getting too much of that we were never adapted to get in the first place. But what a lot of people are missing is that this example of muscles that I just gave and the atrophy that takes place there it is not isolated to just muscles. That happens at almost every level of our physiology. Okay, from the most macro structures of our muscles and our bones and our heart and our brain, to the most micro structures of our mitochondria, to even down to the level of biochemistry with our internal antioxidant defense systems, for example. All of those systems atrophy, degenerate, deteriorate, and fragilize when they are not regularly challenged. So one of the core drivers, mismatched drivers of our modern disease epidemic, is not just harmful forces that stress us and damage us, but it is the systematic degeneration and atrophy of our internal systems that result from lack of being challenged in the ways that we evolved to be challenged. Physical movement being the most important one, but there are many others, like temperature, stress, thermal stress, heat and cold, hypoxia, phytochemicals, and there are many other layers to this story. But we have even neural circuitry in our brain that is designed to be challenged on a regular basis in certain ways. And when it is deprived of those challenges, those areas atrophy and shrink. And this atrophy, for example, at the level of the brain, this is something called this relates to a term in the literature called cognitive reserve capacity or brain reserve capacity. And it has to do with essentially the amount of physical and functional robustness in the neural circuitry of the brain that is built as a direct result of challenging that neural circuitry through, as a result, like essentially the cognitive equivalent of lifting heavy objects or doing physical exercise, education, learning things, doing hard work mentally. And it builds something called cognitive reserve capacity and brain reserve capacity that are enormously protective of dementia and Alzheimer's, because you physically preserve the neural circuitry and the functional robustness of the neural circuitry in the brain. Okay, that principle also extends to mitochondria. So we know that the average 70-year-old has lost 75% of their mitochondrial capacity compared to a young adult. This is like going from a Ferrari V8 engine in your cells when you're 20 years old to a moped engine in your cells when you're 70. So the key distinction to understand here is that it's not purely a matter of harmful forces, sleep deprivation, toxins, bad diet, etc., that are turning your mitochondria off or putting them into cellular defense mode. It's also a matter that the actual physical structures of your mitochondria, the engine of your cells, has literally shrunk to a quarter of its size as you've gotten older. So
Because it's
even
not being
if,
challenged.
and yes, even if you were to remove all the toxins from your environment, not have any psychological stress, eat a perfect diet, okay, have the cleanest water, the cleanest air, and so on, take a bunch of B vitamins and CoQ10 and alpha lipoic acid and other supplements for mitochondrial health, you still have a moped engine in your cells. And this is a key distinction that very few people really understand and appreciate about this whole process. So one of the fundamental pillars that we have to engage in as in order to recover our health and our robustness to more youthful levels is the reintroduction of challenges into our life.
So going back to the example of temperature, and for the people listening who want to do something because this is the best year of your life, so they're going to want to do something. Are we talking like saunas and cold plunges?
Yes. Yeah,
And
absolutely.
then in terms of the cognitive reserve, learning a new language or
Yeah, so there are certain stereotypical things in that realm of Sudoku and crossword puzzles, learning a new language. Dance classes have become popularized as things that are really good for the brain in that regard. The reality of it, there's sort of two key things to understand there. One is there's also things like, sometimes eat with your left hand or, drive home in a new way to challenge yourself to navigate new roads or something to keep your brain active. What's really important, though, is not any particular type of activity as being uniquely better than another activity. It is, number one, most importantly, to do something that you subjectively feel as actually cognitively difficult. So not just engaging in a particular type of activity, but doing a particular type of cognitively demanding activity that you subjectively perceive as actually very hard. Okay? And to the extent that you are engaged in that, hopefully on a daily basis, you're going to keep a lot of cognitive reserve capacity in your brain. Now, if you want to take it to another level, make sure to engage in things that involve systematic progression, okay, that are not just sort of you do the same thing and once you're able to do it, you're able to do it and then it becomes easy, but that it stays hard and keeps being hard for a long period of time. So complex games like chess, for example, are very good in this regard. Learning complex physical skill sets, could be dancing, could be martial arts, could be a sport like tennis, where you're learning complex movements and you keep leveling up is also a good thing. And then diversity of types of cognitive challenges is really important as well because they correspond to different areas of the brain. So things that involve learning new physical skills are also partly a cognitive challenge. So dance, for example, that's going to involve different areas of the brain than learning chess, than learning a language, right? So we have things, if you have a diversity of different types of cognitive challenges and you're working hard, you subjectively feel it's hard cognitive work, and you're doing systematic progression, you're going to maintain a lot of structural and functional robustness in your brain. And if you also happen to have a good diet and have some physical movement in your life, it is extraordinarily unlikely that you will ever get dementia or Alzheimer's disease.
well, we're coming to the end of our time together. It went by very fast, and I think there's so many more things that we could talk about. What is it that you would like to leave the viewers with as far as helping them have the best year of their life?
Well, what comes to mind is actually I realize we have a little bit of an open loop that I want to make sure to close based on something I said earlier. I don't want to leave people with depressing news about their mitochondria shrinking as they get old. So let me complete that thought to make sure that we don't leave people with that little half of the story. Okay, so the other half of the story is that loss of 75% of your mitochondrial capacity as you get to 70 years old, we know is not a natural, normal product of the aging process itself. It is actually the result of our way of life. And the reason that we know that is because when we look at 70-year-olds who are lifelong exercisers, they do not lose 75% of their mitochondrial capacity. They have the same mitochondrial capacity as young adults do. And we also have a number of studies that show that even specific exercise interventions like doing a high intensity interval training intervention for 6 weeks or 8 weeks can recover 25, 35% of your mitochondrial capacity in just a matter of months. So I want to make sure that people aren't left with feeling hopeless. Oh man, that sucks terribly that we lose so much of our mitochondria as we age. It's hopeless. Why even bother trying? No, to the contrary, you should feel very empowered knowing just how malleable and plastic these systems are, that if you even at older ages into your 70s and 80s, you can make dramatic changes to your physiology by engaging in the right behaviors.
Yeah, I mean, I think there's a lot of myths about aging, right? And how we have correlated health and aging, and that we think it's just a sort of downhill after a certain age. That's clearly not the case. And having an understanding of how to eat, exercise, behave, make lifestyle choices that support cellular health and support mitochondria, is, I think, the basis of where we're going in healthcare. At least that's my hope. Because as you said, those things are that's the only thing that's really going to address the chronic disease epidemic that we have.
Yes.
Okay. So besides closing the loop now, what else would you like to say to people to help them live the best year of their life?
Well, I held back, but there was something I wanted to say following up on what you just said there. The trend in our society right now is continuing to go down a path of the type of thinking that I described earlier. So more and more knowledge of disease will lead to more and more sophisticated medical interventions, whether drugs or technologies or the natural version of that that's becoming popular in a lot of functional medicine circles, the same type of thinking, but with natural targeted solutions for specific dysfunctions that are detected. People are going in the direction of more and more technology, more and more comprehensive testing, more and more advanced testing for every nook and cranny of your physiology, leveraging AI, to analyze all these data, genetic testing, and so on. And I just want people to think about this. You may not agree with me now. Maybe you'll think I'm a Luddite and that I'm really not as sophisticated as you, or there'll be people who disagree with me. But I've been studying health since I was a very young kid, and I have a lot of experience in this realm. And I happen to have a different background, educational background, than most people in this space, with a big focus on exercise science and on a very practical level. So I understand the plasticity of human physiology in a different way than people who are educated in a paradigm that emphasizes pathology and pharmacological interventions. And evolutionary biology as well. And what I would be willing to bet a large sum of money that in almost every instance where somebody is trying to recover their health, they would recover it much more effectively and much faster if we sent them to go live with the Tsimane tribe in Bolivia versus if they went to the most sophisticated medical clinic in the world with tens of thousands of dollars of fancy testing and all of the fanciest drugs or natural health interventions and technologies available. Okay, so I want people to just sit with that thought. Again, you may not agree with me, and obviously I'm not actually saying go live with those people. I just want people to understand the principle of what is actually likely to get their health back and the gap between that and what our current cultural narrative is about how to recover health.
I agree with you. I might be a Luddite too, but I agree. And I actually think that a lot of the health recovery that would take place would be because people would be removed from these mismatches and gain a sense of inner peace and a sense of their spiritual nature. And to me, that really is the basis of health to me, as having this understanding that we're connected to an infinite intelligence, far more intelligent than we are.
Mm-hmm. Yeah. Wonderful.
Well, thank you so much for your time. And how can people find out more about you and your work and the Energy Blueprint?
You can go to my website, theenergyblueprint.com or humanoptimization.com. I have various programs and supplements, books, things like that. And I also run a podcast as well.
Yes, I have watched some of your podcast episodes, and I will tell people this man is a wealth of information and really go check out his work.
Thank you so
Thank
much. It was a pleasure
you.
chatting with you.
You too.